of architectures, especially in machine learning methods that's applicable for sentiment analysis. And the last one is the, especially for machine learning techniques, is a training approach and the way how we can exploit the models to get the most for the sentiment analysis. So without further ado, let's start with the sentiment analysis task itself. Is what navigates me to the very beginning of the appearance of such task as sentiment analysis. So sentiment analysis is the task of author's opinion instruction towards the object or many objects mentioned in the text. In case of the relatively short text, is the way how it finds originally, which brings me back to the 2002, where the Peter Turney was one of the researchers who proposed to treat this task in the form of the text classification problem. So given the document, the task is to basically predict whether the text is positive, negative, or neutral. And due to a relatively short amount of size of the text, which could be possible, for example, if we deal with the messages from micro-blogging platforms such as X, Twitter, is that we assume that we deal with the only object mentioned in text. However, this limitation is something that's not always going to be followed in the text. And of course, we may have multiple objects, is what leads us to the next level of the granularity. So that we deal with so-called targeted sentiment analysis, where beside the text itself, we also provide the objects towards which we want to know the sentiment. So for example, within this example, we can assess the sentiment towards the camera or like towards the tripod, where the only one which is to the camera is actually exists in the system, in the text. Besides the actual objects, we also have their categories or aspects according to which we can assess it. So for example, if we're speaking about the laptops domain, so we can assess the laptop as its battery quality, price, performance, and everything else. So all of that becomes an additional parameter within the next level of the detailization of this task, which is dubbed as aspect-based sentiment analysis. And from this point, and once we deal with the short texts, it seems to be there is no any further detailizations for this task. However, and once we switch to the large documents, especially such text when author shares his opinion on the many objects in the form of the analytical text, it may become a case when the subjects or other entities itself becoming a source of opinions, or in other words, we may speak about the attitudes. So the attitude is a relation that is caused by subject towards object in text. So the quick example, just because it may sound complicated, but the case is when the author writing a text and mentions something like, according to certain decision, Moscow is dissatisfied with the Warsaw decision. So within this particular case, we may see that the subject, which is Moscow, has a negative attitude towards the Warsaw. And this is what becomes a source of analysis in the large documents. And in particular, each document could be represented as follows. So it could be a graph where we have nodes as objects with the sentiment connections or attitudes between them. And it's worth to mention that these representation tend to be a very sparse graph with lots of mentioned nodes, but not that much connections, is what also represents a certain difficulties in accomplishing this analysis. So within this presentation, we will be focused on advances of attitude extraction problem. And with this, I'm switching to the following section in this presentation, which is devoted to the advances of machine learning methods. So we first of all provide a little bit details on how we treat this task in order to move forward with methods. So since the task itself is relatively large, we consider to treat them in the form of the small textual parts, double task context. So context is the text part that includes that mentions two objects, and therefore our task is could be accomplished in two different ways. So the first one, we can treat it as the classification of the context, and another way is that we can generate the output by relying on the given the context with mentioned objects in it. So for these two different approaches, we'll take a look how the methods are evolving and what was the advances within the past like 20 years of existence of this task. So first of all, it is worth to mention the rule-based methods besides the machine learning methods, is that they do have such a beneficial main beneficial factor is by being relatively fast, because there is no any training techniques that needs to be applied, as well as resources for performing this computation to matching the patterns. However, and the reason is why it's not that applicable is because due to the dynamics of the textual data and the evolution of like languages and communications, it is so important in that particular case to maintain and up-to-date the collections, is what becomes the main reason why machine learning is applicable here. So switching to the machine learning methods, I would start with the conventional classifiers as the common approach that finds application here, because this is the way how we propose the generalized representation for the text. And this generalized representation is the vectorized representation of the text. So that means if we have collection of the text, we can represent them in the form of vectors that could be illustrated as by being in a two-dimensional space as a cloud of dots, where the separation between them is the application of the different classificational methods. It is also possible to see that there are options how to cope non-linearity of the separation. And in terms of models that would allow us to represent documents in that way, we could mention the such a classical one is the bag of words, where the vector represents the size of the vocabulary. In other words, so all words that could be exist in the language, with such that that appear in a sentence. So besides the advantages that we have against the rule-based methods, is that now we have a generalized representation. The disadvantage is that we don't have a connections and don't know connections between words. And that becomes a source of the kind of next enhancements, and the reason where the neural networks find their application. In terms of sentiment analysis, it finds in the way that we have such a standardized architecture that tend to consist of three main blocks, as you can see on this figure on the slide. So this is the embeddings. It's the vectorized representation of words, followed by the context encoder, and finally is the classifier of the encoded information. So what we can see here is that neural networks that tend to be a generalized optimizers of any transformation, which here in particular transformation on the context towards the labels. And now we have vectorized representation for words, where One of the fundamental model for this could be the one when we just use the so-called one-hot vectors, where we place digit 1 with the related words that is mentioned. However, the next question would be arising here is how we can establish the better connection. And the answer is actually the work that was proposed in 2013 by Thomas Mikolov and the appearance of the so-called textual embeddings. So given a large collections of raw texts, it is possible by using the sliding window and considering the word in the center of the window to calculate their vectorized representation, such that the most similar words tend to be close in the multi-dimensional space. Even more, we can perform the such linear arithmetic operations with these vectors, where the common example is such that woman plus king tend to be a queen. So this breakthrough actually gives a lot of contribution to the application of neural networks and further, despite the fact that it takes additional amount of time to prepare the related resources. So now let's take a look how specifically the embeddings become applicable in neural networks. So during the period and after 2013, I would say up to 2017, there are two common state-of-the-art approaches in the way the embeddings find their application. So the first one comes from the image processing, where we taking a look on the text as an image and convolve its parts with the different convolutional filters and have, as a result, convolutional layers. And the second one approach is when we treat the text in the form of the sequence by passing through the cell of the hidden state, which is so-called and navigate us to the recurrent neural networks. So despite all the advances that both these approaches have, the major limitation was the size of the input context, and especially the more distant connection between most valuable information we have, the less likely we can capture it with these methods. So they're struggling with so-called forgetting information. To cope with this problem, the next step that actually we're taking to advance in this, it's quite interesting, but it comes from the machine translation area of the natural language processing, where there is a common type of architecture that finds their application. It's the encoder-decoder neural networks, where we do have two components, which is encoder and decoder, combined together with the specific vector that performs such a transformation. So the main problem that within this architecture is that the huge payload falls onto this vector in between, and so to say, investigation of such methods that would allow us to extract the most valuable information to this vector would be beneficial to discover, and discover of kind of these techniques is what becomes a reason of the attention mechanism appearance. So in other words, an attention in the way how it moves to the neural networks in sentiment analysis is a specific module that allows to weight the input information alongside with the actual neural network training, so that the most valuable information is counted for the classification. And of course, this technique has become wide distributed with the appearance of the variety of ways of how these weights or attention could be calculated, where the most significant breakthrough was made back in the 2017 with the paper dubbed as "Attention is All You Need." That gave a huge impact on all of the NLP tasks, even until the today, and the way we know the such a transformer architecture, which consists of encoder decoder, but now with self-attention mechanism. However, it's something that we're supposed to pay price for it, and the disadvantage with the self-attention is its computational costs. So it tends to have the square complexity out of the size of the context window. So, and since we have encoder parts, decoder parts, and self-attention, so if we consider only encoder parts, we can deal with such architecture that become very well distributed in NLP, such as BERT. Due to the, again, limitations of the attention mechanism, it has only small size of the input context. But besides that, it could be treated as such a component that extends the embeddings, but to the way that we are learn representation of the original text in such a two artificial tasks. So in particular, as we can see here, we have a bit different input rather than we have in neural networks in the past. We have two input sequences separated by special token. And that allows us to apply two tasks, such as predicting of the hidden words. And the second task is to say whether the sentence 2 continues the sentence 1. So all of that, and during the training process, we actually learn the language representation, and is what represents the next step in the results comparing with the neural networks that we overview on the prior slides. And what about the actual other architectures and decoder parts? Is to cope with the limitations of self-attention. People tend to investigate so-called sparse attention techniques, where instead of attending to every token of our inputs, we just go with the sliding window. That means if by taking a look at this picture, when we have a sliding window out of this wall square, we can re-implement the attention mechanism in that way, such that we have a reduced representation of the attention matrix, is what results in the saving the computation resources and no longer dependency for a square complexity. And of course, within this slide, we can see how this technique become well distributed on the other architecture. So on the top of this, we could see the transformer, which was originally proposed of self-attention. And in the yellow box is the way how it affects the appearance of self-attention architectures such as ETC, LAD, Big Bird, Long T5, and Primera is what becomes such a generative architectures that tend to work with relatively long input sequences. And here is going to be the point where we're actually reaching the most advances that we have at the moment. So every story that happens in the sentiment analysis at the moment is more about the application of the transformers, and depending with the variety of the attention mechanism, depending on the input size and our requirements. So that becomes here within this presentation, the reason we switch to the third part and to talk about what would be the tuning and training techniques that could be applicable for the discussed methods. So speaking about the training techniques, so one of the well-known is when we if we have annotated information, we can use the supervised learning, which is beneficial aspects here is that we have a source of verifying annotated data. However, and the main disadvantage of that is that it takes significant amount of time to manually do this. And here we're coming back to our task originally. So we, again, we're working on the extraction of attitudes. With the following slides, I'm looking forward to illustrate the results that we have in this task with the different training techniques. So the task is that given this extracted context, we're supposed to classify, we're supposed to extract the sentiment relations, which is in that particular case, Trump has negative attitude towards the China and Russia due to the accused in plain devaluation of currencies. So this sentence is a part of the resource. Resource is dubbed as a roue centrale. So this is the collection that consists of 73 documents, not that large, but all the document is kind of saturated with the annotated sentences. So that, and starting with the supervised learning, we got the following results represented on the slide. So these are results obtained by F measure that considers the calculation of precision and recall per each class. And results are not that high, so it says that the task represents quite difficult. So the maximum is 33%, while the expert agreement on this task is 55%. So now let's take a look how we can enhance these results with other training techniques. So basically, this is a starting point. And since we have a few amount of annotated data, in order to enrich our training collection, we can use so-called unsupervised learning or distant supervision. So this is the technique where we using the knowledge base or specific patterns to annotate the data and use this annotation as the source of our training data. So the simple example could be using emoticons, for example, in a Twitter, to convey that whether the sentence is positive or negative. Of course, the disadvantage here is that we do have noisy labeling, so we cannot avoid the incorrect labeling here. But the idea is that if it in general aligns with the correct annotation, it is supposed to enhance the results. And this is the way how we did it for the large documents. The trick here is as follows, is that news titles actually tend to have a relatively simple structure, so that we can find those news titles that has subject and object and mentioned sentiment words in between it, which is tend to be a part of the third-party lexicons. We can do the following thing. We can collect all sentiments and find the most sentiment attitudes as the first iteration through the collection. And the second step is to extract only those attitudes that tend to be the most sentiment. For this, that was a concept that we applied for large collection of raw text that consists of 7 million documents, and extract around 134,000 texts with such titles and the content. And using this for the training approach allows us to enhance results for extra 5% out of the best before that, which is literally not that bad at all. speaking about what will be the next steps after that, is something that is becoming very well distributed within the recent years. And with this, we can talk about the prompt tuning or using the prompts. These are tend to be any information that might be helpful for making the decision. For example, it could be a question answering or natural language inference. We can mimicking the words in the context, or just in any other way provide auxiliary information in the input. And this is where the BERT architecture that we overview is becomes very suitable for this, because of these two sentences that are in input. Sentence number 2 could be used as the extra information or as a prompt. And all of that allows us to even more enhance the results that we see before. And here's the QR code of the wall benchmark that we have for this task, because obviously not all the results were mentioned. And that's becoming kind of final point of the advances that we have in language model applications, the way we can train them. However, and due to the well-known success and the breakthrough during the past year, of course, you can definitely know about the ChatGPT and the way how it's become applicable for all of the NLP domain. That become a rise of so-called large language models. And within the remaining part of this presentation, I highlight the most like recent advances within this and the past year of what would be the results and sentiment analysis of large documents if we consider LLM models. So this is first navigates me to this creepy picture of everything that we seen so far and where we are at the moment. So we have just reviewed unsupervised distance supervision.
Sorry, Nikolai, sorry for interrupting you. I think when you've fiddled in with your microphone, the sound becomes much worse.
All right, because it's like goes up and down. It's like just how about at the moment? Sorry about.
It's great now.
Yeah, okay, I'm gonna be in this position then. Yep. So the final section is we're gonna speak about the large language models, and so the way of how these models are actually placed in this hierarchy of the such a monster of the training techniques, because we overviewed the distance supervision with using like emoticons and processing news titles. We already familiar with the supervised learning, but the reason of the appearance of the ChatGPT and the related LLM models is a so-called recent techniques such as reinforcement learning with human feedback, where people tend to provide the feedback on the way how the large language models tend to perform by answering the questions. So with all of that, now we focused on the application of RLHF as well as LLM models for analyzing the large mass media text. So for this task, we focused on another data set that was proposed in the past year in the form of the competitions. It's more about the targeted sentiment analysis. So the task when we're supposed to extract author position towards the object mentioned in text. This is a data set that represents texts written in Russia, written in Russian, and here's the top 3 results that we have within this competition. So in comparison with the data set we reviewed before, so the best results the participants were achieved was around 62 or 66%, and that's using just the so-called language models. So using the BERT or similar models, but in a fine-tuned way. So considering these results of 62%, let's take a look on how LLMs are performed with this task. And this is what first navigates me to another technique that we can use, which is called as few shot or zero shot learning. So this is the technique when we provide all the information that we provide for the our machine learning methods is just the context itself, and this is it. So the benefits is that we no longer need to spend the time on training our model. However, the drawback is that we may lack of the context, we may result in a misunderstanding from the systems. In some cases, system may provide the answers that are actually are not aligned with the reasoning, which is the so-called hallucinations effects. So we experiment with the most amount of the large language models that are recently available and claimed as tend to be good at reasoning to a certain extent, and compose this table within this data set. So here we can see that the best results we can reach with the zero shot approach was around 49 or 50%, which is 10% less than with the training methods. So what we can get something out of here is that the Mistral is tend to be one of the model with the very good reasoning aspects in the sentiment analysis, as well as the proprietary ChatGPT, both versions 3.5 and 4, tend to perform very in a very competitive way, as well as like a Mistral in this task. That's the first outcome. And second is that it's so important to translate texts in English. So here, as you can see, if your data is differs from the English text, so you may end up with the worse results. And that was the point when we analyzed this. So what would be the source of the mistakes here? And it's pretty interesting that the cases when all the models are actually making mistakes is such examples that you can see on the slide. So, for example, one of the Sweden's most famous actors died in a fire, where we're supposed to find the attitude towards the actor, or another sentence we're supposed to define attitude towards the famous musician. So the problem is like all these contexts looks like a negative, but the thing is, when author is writing this text, he's tend to be sympathize to these objects just because they are, to a certain extent, are very famous. Is that the answer is supposed to be positive? And we experiment additionally, so how to cope with this, and we found that it's could be done once we place the model in a condition when it could chat with itself, and that becomes of another technique which is called zero shot, or just like chain of thoughts inference. So chain of thought inference is the concept where we asking the question in between, for example, let's think step by step, obtaining results, and then combine this result with the original input in order to finally make a decision. However, and using this concept, it would not be a correct way to use in sentiment analysis, because we've tried with that and we found even worse results rather than originally, because models tend to just summarize lots of the opinions and is what tend to become worse rather than just not to use this at all. And here's becomes my main contribution within the very recent advances, is that there is an actual way of how to use this right. And this is the way proposed in the past summer at ACL in a paper of reasoning implicit sentiment with chain of thoughts, where the idea is actually relies on the aspect that we overview as a part of evolution of sentiment analysis. So the idea is that we're supposed to ask for the aspect, whether this aspect exists for the target or not. If exists, then ask for the implicit sentiment. And finally, ask for the result sentiment considering the information that we already obtained within the past steps. And using this technique, we can actually, once train the models, train the large language model with this technique, it's possible to see that results are going to be similar or competitive to the one that were obtained with the BERT-based models. So we believe here is that it's just like a very beginning with these observations, but it's definitely possible to get even higher results that exceed the one we see with just language models. But this has becomes like the very latest step, and the potential contributions are going to be with such chain of thoughts technique. So let me finally summarize what we overview with this lecture. So first of all, we see the evolution of the sentiment analysis task, the way why we end up by dealing with the analyzing of the large documents. We also find that it's better to, we experiment in a way that extract small text parts and performing their classification. And in terms of the actual models, we starting from the rule-based methods, followed by up to the language models, and finally coming to the specific training techniques that involves a chain of thoughts. The main conclusion I can mention is that the crucial part of the optimizations are the prompts. And it's interesting to see that now they are in the form of the text, but in past they exist in the form of the features. So with this, I'm just going to say that prompts still remains such a huge part in the LLM, is like a one-on-one monolith component, without which we do not have a good results in sentiment analysis. And I also didn't mention that there are also specific training techniques for such a large models, as well as I would recommend to also take a look on the interesting studies on how this attention and understanding of information would work depending on the question is placed in the context. And finally, there are two slides and the way, because you may wonder, so these studies exist, but what would be about their application? So the one of the measure application is that during the work with this task, we end up by releasing the framework, which is aimed on the processing of the large sequence of documents in the form of two separate pipelines. So the concept is that we have a separate pipeline for annotation relations, as well as the pipeline for the annotation of text, which is more efficient rather than existing approach that focused on the only single document. And this pipeline becomes a part of the system that could visually illustrate the way how we can work and see the relations, and that is dubbed as AirLite, that is going to be proposed with the ECR 2024 in Glasgow. Is the one demo that illustrates the importance of attitudes extraction. And that's everything from my side. Thank you very much for your attention, and I will be delighted to answer your questions.